Okay, so here we go. We are starting solving inequalities with absolute value. This is section 9.4. So let's quickly review what is a conjunction. Let's go, McKenna.
A conjunction is an intersection.
It's an intersection. So that means a disjunction is what? Yep. It's a union. So conjunction is an intersection. And what word do we use to describe an intersection? And or? Yep. And. Okay. What word do we use to describe a union, everybody? Or. That's right. Okay. So conjunction is an intersection and we use and. Disjunction is a union and we use or. Is everybody clear on that? Yeah. Okay. Conjunction includes only what's in common in your solution set, the commonalities. Disjunction, union, includes everything. Everybody from this club, everybody from that club is included in the solution set. All right, so when we have absolute value when we have an inequality touching the absolute value, we basically are going to do the same thing we were doing with the absolute value equations. We set one equal to the positive, and then we set one equal to the negative. But if I'm setting it equal to the negative, isn't that like setting it equal to the opposite? What do you think we would do with the inequality? Yes?
To switch the sign.
We're going to have to flip. So if I set it equal to the opposite, not just the negative, the opposite, then I have to flip the inequality. Does that make sense? Leave it. Okay. So now, and again, I'm going to do the same thing. I'm going to have, and you're writing everything I'm writing. Okay. The next one is going to read, do you think this is an and or an or statement? It's an or because we've already got the and. Now, we're going to have x is greater than k, or what would I write? Or, Chris?
X is less than negative k.
X is less than negative k. Good. Okay, now, there's a quick way to kind of like remind yourself there's a little trick. And so the first trick for the and is when you have the less than is touching the absolute value, it's always going to be an and. And how do I remember that? Well, let's first look. Less than is always touching the absolute value. It's an and statement. And when great or is touching the absolute value, it is an or statement. So I use these phrases, less than, everybody say less than, and great or, okay? So when the great or is touching, it is a or statement. An or statement, now we're working backwards, is a union. A union should look like what on the number line? 1 or 2 lines? 2. Good. An and should look like what on a number line? 1 line, right? Okay, questions? So let's just, now this is on the average. Let's add all this other stuff. This is a union. We know it's an or statement, and it basically should look like this, right? Now sometimes that's the norm, but sometimes it overlaps, and we get that all real numbers. This one is a intersection, and it is most of the time going to look like 1 line on the number line. We call this a conjunction, and this a disjunction. So just reminding everybody of everything. All right? So you ready to do this? When less than is touching, it's a and. When great or is touching, it's a or. Okay? Can I erase?
Yeah.
Who said no? All right. Here we go. So let's do our first one. So I'm going to branch it. The first thing I'm going to do, I see absolute value. That means there's two possible solutions. Why? A negative value could go in there and make it a true statement, because once I take the absolute value, it'll be true. And then a positive. So let's write this one. We're going to branch it, and we're going to say x is less than 5. Is this an and or an or statement? And then what am I going to write? Okay, Chris?
X is greater than negative 5.
X is greater than negative 5. So noticing that we flipped our inequality around because we went from 5 to negative 5, right? Just noticing that. All right, and now I'm going to just follow the directions. Now, if it's an and statement, it really should work with the smallest one being at the left. How do I write the in-between statement? Who remembers how to write that, Jordan?
Negative 5 is less than x, which is less than 5.
Perfect. Okay, and let's just double check. X is less than 5. That open area should be near the 5, yes. And this one with negative 5 should be the small point touching it. So I'm just double checking it. That's right. All right, and then I go to graph it. And what are the numbers I need on my number line now? Let's go with Daniela.
Negative 5 and 5.
And one more.
0.
And 0, just to show the relationship of where it is on the number line. So I'm going to start with, is it an open or a solid circle? Open. And we're just going to do one line going from one section to the other because that's the only area that shows intersection. Now, I had a lot of people, can I stop this? I'm going to go back. I had a lot of people doing this. Okay, that doesn't show me an intersection because you're showing me more than an intersection. You're showing me this and you're showing me this. I only want the intersection. So the best way to really do it, the first time we taught you was with this. But really, all I want to see is the single line. Only the intersection. Does that make sense? Or you're going to be marked off. Okay, so the next one, is this an and or an or statement? Or, because great or is touching. So I'm going to start with the first one, and what is it called? How's it going to read? Savannah?
X is greater than 5.
Or?
Or x is less than negative 5.
Perfect. Now, can I write this as an in-between statement? No, I have to go right to the graphing. And I'm just going to start, and I'm going to follow the directions. On the first one, it says x is greater than 5. So I start at the 5. The second one reads x is less than negative 5. So that's pretty straightforward. Everybody understanding the great or less than?
Yes.
Okay. Now let's hit some. Okay. Why don't you guys try this next one? Go. Pause the recording. All right, so I'm going to continue, and I'm going to set it up the same way. I'm going to break it up into the two equations. Hands down for right now. So I have x is less than or equal to negative 2. Is this an and or an or statement? And. And then I have x is what?
Greater than or equal to 2.
To positive 2. So if it's a positive 2, it's the opposite. I still have to flip the inequality. I see a lot of hands up, but I'm going to keep going. I'm going to put you on hold. I bet I know what you're going to say, but I'm going to keep going, and let's take a look at this. This is an and statement, right? What does that mean? Yes.
It has to be both.
Okay, what does it mean, though? Yeah, both. What does that mean? Doesn't include it. It has to be intersection. Okay? Only the parts that are included in both, like she said. So now I'm going to graph it, and I got to follow the directions. The first direction says x is less than negative 2. Boom. The second direction says x is greater than 2. So where is that my solution? Why? I heard there is no solution. Why?
Because it's a negative 2 and it's so
No, why from the graph? Yes.
Because they don't intersect anywhere.
There's no intersection on this graph. So we can see that here. But back from the beginning, right away at the beginning, I noticed a lot of people had their hands up and they were noticing it here. It doesn't mean that that's the only place you can see it. Why can we tell from the equation? Savannah?
because if something's an absolute value, it can't be negative.
It can't be less than negative 2, which would include all negatives. So that in itself is a no solution statement. Right away, we realize that absolute value can't be less than negative 2. Negative 3, negative 4, negative 5. So I saw people right away jumping to no solution. But let's just say I go on with the math. We can see it here. There's no solution because there's no area of intersection. Does that make sense? All right, so now let's go on for the next one. The first one, Kendall, what am I setting? What's it going to look like when I branch it?
X is greater
Greater than or equal to negative 2. And what kind of statement is it, and or?
or
Good. And then the other equation would be,
me.
yep,
X is less than or equal to positive 2.
that's correct. And then I'm just going to go straight to graphing because I can't write this as an in-between. So I take my number line, and now we're going to start graphing. X is greater than or equal to negative 2. You should be writing what I'm writing. So I'm starting on the first one, and I'm going greater than or equal to negative 2. Okay, now x is less than or equal to, I'd like to pretend that this doesn't say equal to. Okay, let's get rid of that. The next one, x is less than 2. Tell me what this means. Ben.
It's no solution because
First of all, an or, is it an intersection or a union? What?
union.
It's a union. So a union means these people, this set, and this set.
But if there's an intersection,
It doesn't, just because there's an intersection, it means all of these numbers are invited. This group and that group. So make sense of that, Christina.
All numbers apply.
We don't say all numbers, we say all what kind of numbers? All real numbers, because we're working with the real number system. Okay? All real numbers. Absolutely. Okay, it's the opposite of what you're saying. It's all real numbers because everything in red and everything in blue. Now notice, some people say all real numbers and then they leave this empty. You're not leaving this empty. You don't do this. Because as you're going through with that red line, it goes through the blue opening and it picks it up. Do you understand? It picks that number into the number of solutions. And then with the blue one, as I'm doing that circle and I go all the way, I'm going all the way through it. Does that make sense? And we would make a statement like all real numbers. X is such that X is all real numbers. Does that make sense? Yes or no? Now, you've got kind of two different, these are, I don't like the two lines because you're not differentiating between when it's an intersection. I want to see one line or two lines that like go on and on. I would like to see one line going through you to tell me almost like be on top of each other. Because a lot of people from your intersections look just like this. Do you understand what I'm saying? This is not just an intersection, it's a union of both. So really, by rights, the number line should be this, with the point going through. It's all real numbers. So we're writing all real numbers. Questions there? Yeah.
Do we have to draw the circles at each number?
Well, you should, because you want to show me that it's getting picked up there. Okay? Where is it starting? Okay, now we have an equation. We're going to do the same, well, really an inequality with using properties of equality. So now we're going to, what do we do with this one? Let's go with, let me see here from, how about Daniel?
So then you break it up into two equations.
Mm-hmm.
So you start with x minus 5 is less than 3. And then x minus 5 is greater than negative 3.
Okay, what kind of problem is this, Sophia? Is it and or?
Or?
Look at the symbol that's touching.
And.
Less than. Okay, so what did you say it was? X minus 5.
Is less than 3, and x minus 5 is greater than negative 3.
I want to see that and there. Okay, are there any questions there? Wait, and what did you say? X minus 3?
X minus 5 is greater than negative 3.
Good. He's switching the inequality around, and he's switching the sign of the second one. Okay, you guys finish it? Go. Let's check our work. We're going to use properties of equality. Add 5 to both sides. You get x is less than 8. We're going to add 5 to both sides. X is greater than 2. It's an and statement, so we go from minimum to maximum. 2 is less than x, which is less than 8. And then we graph it. How many lines? What? One line. Opening at 2, stopping at 8. We have 3 digits on the line, 0, 2, and 8. And you guys, don't put them equal amounts. Miss Sophia's going to go crazy on that. I will see her knock off if you do this. 0, 2, 8. At the bare minimum, 0, 2, 8. You understand what I'm saying? It doesn't have to be exact, but yes, question.
Well, I was just going to say, like, if it's a really big number, like, do you have to count
Well,
that?
but you don't have to, no, you don't have to count it out, but you can do, oops, here. So let's say we're going, we've got 0 to 100.
Okay.
I can do a big space there, right? All right, let's look at the next one. You guys ready to try this one on your own? Okay, pause the recording and try the next one. Let's check our answers. So we're branching it out. Is this an and or an or statement? Or, because great, or 1 or 2 lines on the graph. Should be 2. Okay, so we should have gotten x is greater than or equal to 6, or x is less than or equal to negative 3. Did anybody get anything any different? Okay. And, you know, mistakes are not a problem. We want to track the mistakes and figure out where we're going wrong. So we're starting at negative 3, and we're following. This was, I did this last period, and we just started, we went in robot mode, and we did this. We forgot to make sense of what it is. Right before you graph, make sense of that or. It should be 2 statements. I didn't follow the directions. That's not the right way. Follow the directions. I'm starting at the 6. It's an open circle, and I'm going to the right. It's bigger than. It's a solid circle. And then on the other one, I'm starting at the 3. It's a solid circle, and I'm going to the left. Questions? Okay. Okay. All right. So now I want to do a couple more with you. One, we're going to do this, and then I'm going to change this equation to something else. All right. You want to try this one on your own?
Yeah.
Okay, pause it. Go. What are we doing first? Step 1. Somebody haven't heard. Alexander.
First you add 6 to both sides.
Adding 6 to both sides.
And then you divide both sides by 2.
Dividing both sides by 2.
And then after that you branch it off.
We're going to branch it off.
And you would get
Is this and now, this is the point that you determine whether it is an and or an or statement. Is this an and or statement?
is
And statement. We don't make that determination until we isolate it. It's an and, that means it should be one line on the number line. Okay. And it's
x minus 4 is less than or equal to 8. And x minus 4 is greater than or equal to negative 8.
good. And now we're going to add 4 to both sides. And it's an and statement, so I get the in between. And when I go to graph it, it's going to look like, oops, I have no room here. It's going to look like this. I have negative 4, I have 0, and I have 12. And it is a solid circle. Right? Just to there. All right. Now, last problem. Okay. It is going to be negative 2, absolute value, x minus 4, minus 6 is less than 10. Okay. Step 1, what are we doing? What are we doing?
Add 6
Mary.
to both sides.
Okay, add 6 to both sides. Adding 6, I'm adding 6. Negative 2, absolute value, x minus 4. Now, if I look at the beginning right here, it looks like it's an and statement. It's an intersection. But once I isolate, what happens now, Kendall? What do I do next?
Divide by -2.
And when I divide by a negative, what happens, Kendall? I flip that inequality, and I get the absolute value of x minus 4 is what? Kendall?
Oh, -8.
Is what? Absolute value
Greater than negative.
is greater than negative 4. You guys with me? So this is the moment that we get to determine whether it's going to be an intersection or a union. Oh, sorry, 8. Sorry. Do you understand that? We do not determine until the absolute value is alone. Now, I'm going to branch it off, and we end up with, x minus 4 is greater than negative 8. X minus 4 is less than positive 8. Add 4, add 4. X is greater than negative 4. We said this is a what kind of statement? Or, because right here in the middle, and the other one I'm going to be add 4, x is less than 12. Now I'm going to graph it. I need negative 4, I need 0, and I need 12. Now, I got to read my solutions. X is greater than, I'm going to do this one in blue. X is greater than negative 4. I start here, it's an open circle. I'm going all the way through everything there. It's a union. It includes every number bigger than -4, but not including -4. Okay, so now I'm going all the way through every single number greater than -4, but not including -4. Now, I should see, for the next one, it says, or, it could be either or. All numbers greater than -4 are invited to the party, or anybody less than 12. So I start at 12. Notice that circle is right there. I'm seeing it go through. And I need to make that line go through so it picks up that 4. Because isn't -4 less than 12? So it gets picked up in that solution group. So what does this mean? Adam?
It's all real numbers.
All real numbers. And you need to make that statement. Cubby.
I complete the entire question, but I knew it was all real numbers from like the start, like right when we got it to absolute value x minus 4 greater than -8.
Why do you say it's going to be all, why do you say,
It's like greater than -8, which is like 4, but then both the sign, and then I just knew because it was like, and then
but we don't get points for just having intuition. You've got to prove your way to it being all real numbers. Anything you're going to get paid for and use the math for, because really there's not a lot of, hold on. Okay, that's the end of the lesson. But you've got to basically prove your way through to the end. You know, I don't want to go on intuition. I'm not grading on intuition. It's an algebra class. We're proving with algebra. Okay,